Hello everyone. Welcome to another Google Cloud Lab session. So this is Suresh. So in this lab, we will look into classifying images with neural network and a deep neural network model. So without any further delay, let me start the lab. So in this lab, we will only complete the tasks provided for us. So and also there won't be much discussion about any theoretical or technical stuff. We are only going to execute the code provided for us and see how this works in the Google Cloud console. So let me open uh, the incognito window. And start. Let me do the setup first. So at any point in time, you can pause the video um, and check for the status or go to the overview and the learning objectives. So this is the overview of this lab and the learning objectives. So defining helper functions and train and evaluate neural networks and the DNN models. Wi-Fi is a bit slow. Just give me a second. Let me try to change it. Now, so the setup and requirements is just completed. So let's see what is provided in the task one. In the task one, we are going into the workbench, Vertex AI dashboard. Yeah, this is a little bit faster. Wi-Fi is very fast. Okay. Enable all recommended APIs and also navigate to the workbench as specified in step 3. At the top of the ensure you have instances. Yes, we have instances and click on create new. I'm going this to name to lab workbench, central 1A zone, region and zone. And advanced option further customization. We are not going to do this any further customization. We just continue with what is provided as default. Click on continue on the environment as well. And you can see by default E2 standard 4 system machine, virtual machine will be there. And also balanced persistent disk of 100 GB. Continue with the networking, continue with the IAM and security. Click on create. So this is going to take about 2 to 3 minutes to enable the open Jupyter Lab. So it will take 2 to 3 minutes. So let me pause the tab, and once this is up, I can resume it. Now you can see the open Jupyter Lab is enabled. So let me click on it. It's going to open a new tab. Let's wait for the Jupyter Lab to be displayed for us. Select the Python 3 from the notebook and rename this notebook. And full name, and inside this, let's check the progress. Let's clone this repository. Let's type this shift enter. So this is going to take a few seconds. Once that is downloaded, we will navigate to this place. cloning is also completed, but the cloning is still in progress. Let's wait for it to complete. So task 2 is also completed. So let's move on to the task 3. Now you can see training data analyst, courses, machine learning, deep dive 2, computer vision 1, labs, classifying images with NN and DNN model. We open this for the interest of the time, right? So we can select this TensorFlow 211 as provided in step 2. Okay. So for the interest of time, right? What I will do is like I will open the solutions as well. You can see the complete solution of this notebook. For that, let me clear all outputs. All outputs are gone. So we'll navigate one step back, go back to the solutions, in an DNN model. Selecting the but we are not going to execute the solutions. We will execute, let me minimize this, we'll execute the main lab session. I'm just minimizing so that you can view more of the code. So first we will try with TensorFlow version. You can see the kernel is busy. So we need to wait until the kernel will get idle. So 2.11 is the TensorFlow version. So let's install the graph in the Conda. Okay. Again, this helper functions. So I'm not getting into the details of this helper functions so that either you can pause the video or clone the repository and go through the content and understand what this code is and how this code works. So basically, this is having about mostly three. This is having three helper functions. One is training plot, second is plot predictions, and third is show trained weights. Again, for this each and every element, there is a separate classes available uh, where you can go and do some research on your own, understand what is plot or how to define a function. So let's define the function. Helper functions. Okay, this is done. So no errors. Coming back to here. Now from here we will do some activity. Here importing the files, required libraries. Here we have to read a file. For that, the solutions. Copy the code from HDFIO 8559. The file name, where you can see the file name is so this is a to do one. Yeah, I don't see any other. So combines both operations, punish the search. So read and decode. So shift enter. There are available classes dicey, dandelion, roses, and cloning tulips. Okay, it's good. Now train and evaluate neural network model. So this is the first phase. First phase, you can pause the video and get into this. So here at the high level, we are going to see that this is using a sigmoid and YELO functions activations. YELO and YELO activation. So sigmoid activation, YELO activation, and as well as agent activation. So let's enter So you can see the sigmoid, how the sigmoid will. Now here we have the model. This is having the sequential model. So this flattens the height and the width with the channels, three channels, and activation function as well. And this is having 128 nodes, and the activation is softmax. This is having length of class names. Basically, class names. That is what we have seen. Okay. So let's enter, and you can see the additional information. This is having about 150 by 28 uh, uh, parameters, features. I will call it as features, and this is having 128 nodes and 5 nodes in the dense one and 2 node. And the total parameters is 19 million. Okay, and you can see this. This 150 by 28 is nothing but 24 times 224 times 224 times. So there is a pattern here. Now there is another sequential, so we are flattening it as well. Now let's go back to, we have to see the history here. So let's go back to the second. Let's neural network model. Again, I'm not getting more details with respect to the lines of code because this is a huge, this is a kind of, it will become another session for going through the line by line. Okay. The main intention of this course is to only to execute the code provided in lab sessions provided in Google Cloud and execute a task. So let's execute. Now you can see epochs. We have seen 10 epochs. Let me complete the one epoch completely and see that. And I will pause the video. And after the 10 epochs, again, I will resume the video and show how the all epochs has been progressed. Very slow. It is 19. I don't know how many 32 batches. At least I should have to see 320. Is unknown. That is also this whole process might take about 10 to 15 minutes as well. Let's wait. I'll pause the video and I will first just start with when the epoch 1 completes. I will. So after 2 to 3 minutes, now you can see one epoch is completed, that is having 104 data. So, and you can see the other information like loss, accuracy, and value loss and value accuracy. So I'll pause the video and I will let all epochs to get completed. Okay, now you can see the all the epochs has been completed, and you can see it took around 9:28 seconds, almost 15 to 18 minutes. And you can see the loss has been gradually started reducing, and a little bit of in the epoch 7 has been just a little bit increased and then gradually decreased again. And also the accuracy started to grow. So in between 0.5 again came back down, and also value accuracy similar pattern we will see, and also value loss as well. So let's plot this. Yeah. Now you can see the similar lines just got down, got increased again. So again, I'm not getting into more details of these epochs, value accuracy loss. This we can go back. And now training the neural networks. So let me see if there is anything to do. Click enter. Looks good. First, train the model by using 128 layers. Okay. Learning rate is batch size is 32. Learning rate is 0.0001. L1 and L2. Layer 1, layer 2, 0, 128. Shift enter. Again, I will wait for this step to complete. So this is having 128 hidden layers. So let me pause the video and I will let it complete. Okay. So if you see this model and evaluate with 128 hidden layers, it took about 405 seconds. And you can see the training model. And you can pause the video and go through the each across how was the losses got reduced and accuracy got improved and the value loss as well as the value accuracy details. And this is the graphical representation of the scene. And now let's do it for the 256 hidden layers. Previously it was done for 128. We will again train and evaluate with a batch size of 32 and the learning rate of 0.0001 and L1 and L2 as zeros. Let's start training the 256 layer. Again, this is going to take some time, so I'll pause the video and I will again show it. We'll do a comparison. So with the 256 hidden layers, it took me about 5 minutes, almost 10 minutes. You can see the epochs, so and you can see some epochs. There is some variations. There is an ups and downs with respect to the loss and also with respect to accuracy and the loss and value accuracy. You can see the same in the graphs that is plotted for us. So, so when you have time, so you can go to this first 128 hidden layers plot. You can take the snapshot and with respect to the 256 hidden layer. So now let's move on and train and evaluate deep neural network. Okay, no issues. And then let's put a model here. Let's go here. So this time we are training and evaluating. Learning rate is 0.001. L2 is 0.0. Number of hidden layers are 64 into 16. So let's play this model. Now we can see flower classification is started and we have something in the dense layer. Hidden dense layer that we have about 9 million. And again, this one I will have this paused. Once all the epochs is completed, then I will show. Now you can see this model training has been completed and it took about almost less than 9 minutes. You can see the loss is gradually got reduced as well as the accuracy got increased. And you can see the compare the plots. So this concludes our session. So I hope this will be more informative, at least with respect to what we are just trying to execute. So instead of going through the step by step. To learn this, either you can clone the repository as the mentioned provided in this. Let me complete this task as well. So you can see, and you can clone this repository provided here, and then you can go to the text, go to the code that is shared in this. Yeah, thank you very much. And our score is 100/500. Thank you very much. Have a great day.